Welcome back. Really excited today. I'm finally getting around to being able to take everyone through my brew panel, like I've been wanting to. I've been wanting to do a video that's just kind of like the overview of the panel, all the thought processes that went into the design and materials and everything of what I chose in order to build this. Just kind of like a follow-on from that six-part series that I did previously. We'll talk about the overall system. I got my kettles out here, and I'll go into kind of like electric brewing and just kind of like the takeaways that I had, after I got this built, anything I might have changed, anything like that. So here we go. Before we get into anything too far, this video is strictly for educational purposes. Any wiring, you want to get a licensed electrician. And I'm going to be throwing out my list of materials who I went to, and a lot of research and everything. Went to a couple different websites. I'm not sponsored. That's just the sites that I went to. They were extremely helpful in my design and in the direction I went in making my panels. So if they're on there, please support them. We jump right in. So this is my panel. You'll see it in my six-part build series. I literally show every single step of making this from scratch. There's all kinds of prefab panels out there that you can buy and either do the wiring yourself, or you can buy it already wired up and you literally just got to hook it into your power feed. To each his own. I really enjoy building the things that I brew with, and this too was kind of a one-off piece because I was really trying to make it fit in this location, which is ideal for my brew setup. So I'll take you through all the stuff on the panel here. Obviously an on and off switch. You could go ahead and utilize the breaker, especially being this close to the panel, if you wanted to. This is just really convenient. I've gotten a habit too of hitting my EPO, but everything with this design was, every thought went into like space. Some people have a lot more room in their brewery, 16 by 16 panels, 20 by 20 panels, and I just don't have that kind of footprint. So everything I did was designed to make this as compact as possible, but still have the functionality that I wanted to have in the system I wanted to do. And I'll speak about the different systems here in just a second. I have my three timer, or my three PIDs, very small timer. These are my element indicators. My switches here to turn on each pump, element switch, and then these are all my timers. I have a master timer switch, which is going to be off of the actual timer itself, and the other ones are actually just PID alarms for high-low temp. These things are all pretty versatile. There's different controllers available. You can get Love, I think Siemens. These are the Auber, I think that's how you pronounce it. Definitely wanted to do the buzzer, key with when the timers go off before I hit high-low temp, especially if I'm overdoing hops or anything like that, or just working something, measuring grains or whatever it is. This goes off, clear audible, and then this is just my stop reset button, one of the inputs that the timer will take to go ahead and reset. If you want to get fancy, you can have a start button and stop button and all that stuff, but again, I don't have a lot of space on this, so this is what I went with. Things you can do to save space, like I did here, right, is I went with a volt amp meter combo rather than having the two separate displays. Not only did it save a little bit of money, but it also saved that space. And this is still something I wanted to be able to see. If I really wanted to go micro, if you want to call it that, I could have potentially removed my EPO. I probably could have got rid of the volt amp timer. I could have got rid of my alarm switches and and really made it smaller, but again, coming back, I wanted to have that functionality. So going back to this, like, why am I trying to go this small? Just given this location here right next to my electric panel, I wanted to be close because this cable's not cheap to like if I wanted to put it halfway across my garage or something. And you see here, this is the This is the rail for my garage, which I didn't really want to be like this is a 6-inch depth box. I would have been out here. It just seems like in this kind of like little space I have here, it would have really started to protrude. So I didn't want to be out past this rail for my garage door, and I needed it to fit in this space here between the garage door and my box. So this is actually a 12-inch wide panel and by 16. And I didn't originally want to do a 16. I wanted to try to do a 12 by 12. I'm really glad I went with the 16 because the 12 by 12 would not have worked. But this has ended up just being the size that I was able to find for a box. Things I really had to consider in doing this smaller box, I had to go with some different heat sinks in order for the depth of the box. And I'm going with I think these are like 4x4s is what they ended up being, and then one for each SSR. And I mean, really just lots and lots and lots of engineering. I think I'll probably have links to this stuff too, but this is what I drew up in AutoCAD. Everything based off of actual measurements with the box I had laid out with all my measurements when I made this, and I think the first part of my series shows all that. But plan. Everything of where it went was laid out, verified it would fit. I had actual cutouts for all this stuff, and then I think I used quarters or something or nickels for all these and laid it on the panel and just like, is this thing legit gonna fit? And then the biggest thing is like, is it gonna fit inside the box with all the wiring? And we'll look at that here in a second. Wiring diagram, I can also throw that up as well. This is something I pulled from, I think it's Electric Brewery. The link's in the LOM. Again, every single wire connection was planned out prior to ever doing anything. Before I bought the first piece of materials for this thing, I had it all laid out of what it was going to look like. And in doing all that preparation and having that thought in your head is how you're going to be set up for success to have a functioning final product just the way you wanted it, or hopefully in your case. But it did work out for me. So I want to back up and kind of talk about the system again for a second before we open up the inside of this box. We'll look at the plugs on the bottom and everything like that, and start to go into the guts of this thing. When you're looking at doing your panel, you have a couple options, and if you look at some of the commercial systems that are offered, and then just various builds from other websites, you can do a HERMS setup or you can do a RIM setup. Both have their advantages and disadvantages. If you read up on it, you can determine what's going to work best for you. I chose to go, with old school, proven HERMS setup. Being that this panel, and you'll see the number on my list of materials, I think I was rated about $1,000 or $1,100 or something like that, and that was even with having a lot of the materials on hand already, and did not include prices for my kettles or anything. This is still kind of like just built in stages for me, which I would assume is probably the case for most people. Anyway, so HERMS setup, that's going to take the 3 PIDs. You're going to have one control your hot liquor tank, the mash tun, and that's not really to control, but really just to monitor kind of where you're at, if you need to bump your temperature up or down, and then your boil PID. I did see a couple really cool designs where they just had like a larger potentiometer to do that. You could totally do that, because with that you end up having it on manual mode anyways, and you're really just looking for a boil. However, I found too, it is really kind of nice to see what temp you're at, how fast it's climbing and stuff like that. So I mean, with this thing, this is like a spaceship, man. You see everything that's happening with your brew, all in this panel. It's really nice. Something I'm incredibly happy that I chose to go ahead and do, and I'm never going back. So looking at the kettles, this is what I have currently. Prior to doing my panel, I did a ton of Bruna bags. This was actually the first kettle I ever owned. So I jumped to this, and then rapidly realized I needed to go to all grain to really be able to do what I wanted to do. But still used in my brew setup with this panel. And then I wanted to jump to doing double batch recipes, which have a ton of videos on both these setups, but went with this larger 22-gallon kettle, and this thing does great, excellent kettle. But looking at adapting that to my HERMS setup, the plan is to, this kettle would still just be potentially my brewing bag for kind of test recipes, so to speak, because it's just a lot easier to manage than it is with doing a smaller volume recipe with this. But plan is to go ahead and get another one of these 22-gallon kettles and use that for my hot liquor tank slash be the the other piece of the HERM setup where you have your coil inside of this and you're pumping your mash through. So HERM system, heat exchange, recirculating mash. The mash is leaving your mash tun, being pumped through the coil in here, getting that heat exchange from the water in your hot liquor tank, and then entering back into your mash tun, versus a rim system where you literally just take the water out of your mash tun, run it through a rims tube where you apply direct heat to it, bring it up to whatever temp you need to be at, and then it filters back in to the mash tun. Rims is a recirculating infusion mash system. Yep, that's right. Both of them work really well. They're both cycling that liquid through your mash, which is really good. I found being able to do that really helps with efficiency and just keeping a real good consistent temperature in your grain bed, which is always good. But with the rims, from what I can tell, and I would not say I'm like an expert on this, but like with the rims, you still you have to maintain temp in your hot liquor tank yet, or have it like in a cooler where it's going to hold temp really well, and then be able to apply heat with your rims tubes. So you're looking at having two elements hot at a time, which is going to exceed your 30 amp capacity. At least that's how I interpreted it. You could do the advantages of doing rims if you want to do a real simple panel is you can still do like propane or something for your hot liquor tank and your boil, and then just have the electronic piece control just your mash, controlling the temperature of that mash, that's the real critical piece. And it's nice because the rims advantages, the rims is going to bring that temperature up very quickly, versus it's a little bit slower with doing a heat exchange or circulating mash. However, it still works. It's tried and proven. But that's what I chose to go with. That's why I still have kind of these two kettles. My current setup, if you see a couple of my last brews, I'm still doing tons of brew in a bag with this, using the PID to, I'm recirculating the mash in there. PID is holding it at a temp. They've turned out really well, incredible efficiency. And I still do a double batch system with my larger kettle. It's just I'm not able to recirculate that mash in my cooler because I don't really have a way to heat it yet. I need a second pump and my coil and all that stuff, but still works. Pieces I still need to build on. But so back to the panel here. Looking at the bottom of the panel here, this is where the magic happens. I have both 30 amp L6s cut right into the bottom of the box. Everything's labeled, and you see my 110 outlet over here. A lot of setups have the twist lock for the 110, where I chose to not do that, just really due to space, and I'm just running a pump. I didn't think it was really that critical. Still turned out incredibly well. And then of course on the left there you see all my temperature probe connections all lined out. Again, all of this was planned out, measured out in AutoCAD so that I knew where to go. Cutting everything in was done by hand. It turned out really well. And then on the right there you see that's my input feed from my main electric panel here. Back from the panel. So connections off of those pieces on the bottom of the panel. All my temperature probes, this is pretty standard. And I bought these pre-made. Do recommend the silicone jacketed stuff. It's so much easier to clean, and I believe these were 12 footers. but again, on the list of materials. So 3 of these went with different colors, so I knew which one was connecting what, and those get all rolled out at brew day. You'll notice a lot of this stuff, I don't have like a nice fixed rig or space or anything, so I got to kind of set this all up every time, but it works well. These are the cables for, got a shorter one and a smaller one. These are my cables to feed the elements. So currently using this is my boil kettle, and then I use this as my hot liquor tank, and then still use my good old-fashioned cooler as my mash tun. I got the fitting in there so I can see my mash tun temperature, and and then these obviously have their probes in there. So we'll go through that on the kettle real quick. Temperature probe on this. This is my Whirlpool port on both of them, and then you'll see this on a couple of my other videos as well, though. But this is the tri-clamp weldless insert with the ripple element in there. It's a 5500 watt ultra low watt density element, and I do have a little bit hotter voltage here. I'm actually running about 259, 260, which you run through Ohm's law. I'm actually getting more than 5500 watts, and this thing is screaming on how fast it heats water up. All of that stuff you can order in bulk, or there's pre-made cords. Again, all the websites that I have in my list of materials have a wealth of electronic brewing pieces to it, and you can decide really what's going to work best for you. I had these whips available to me. A lot of stuff I tried to repurpose on hand just to save a couple bucks. Let's get the panel opened up. All right. Panel does kick on. I'm going to go ahead and kill power to that because self-preservation instinct. All right, breaker's off. You can see it's not firing, so it's dead. Again, very small panel, and it took a lot of thought and and design and everything to get everything to fit in here and be able to work like I wanted it to work. So coming through, this is power in. You see here, this is a backplane that everything's screwed to, and the big thing with all of this is I chose to go with the DIN rail components. You might be able to fit this stuff in here if you just went with conventional components. However, I didn't want to take that risk, and honestly, I think the DIN rails look a lot nicer aesthetically, and they also helped with the space a lot. Again, everything was laid out and measured and remeasured, and you can see that on my 6-day build process. I have my main coil coming in. This is triggered by the key switch. The only other piece that actually is hot in the panel when that key is off is just literally the power to go up to the key to be able to turn it on. So all the PIDs and everything goes through this 6-amp breaker. And then I do have a really small, I cannot remember the amperage, and I'm not going to take it apart to find out, but it's really small. Let's see if I can see it in here somewhere. But it's just a small AGC slow blow to protect the PIDs. They do not require a lot of amperage, obviously, and I didn't want anything to be able to damage those. Going into it, here's the 2 relays for hot liquor tank and boil. All of my outlets here in the bottom, I took this 110 outlet and split it in half, because really I only need the one plug, and again, that really helped me save on space. And if you look in here, I mean, this thing is packed. It was a real challenge to get everything to fit in here and retain, be able to have the functionality that I wanted to have. Like these guys down here, incredibly close to the bottom. All the side pieces, literally had to rotate these to the side to get them to fit. But here, EPO, LEDs, all my switches and everything. A lot of effort going into this. And then, of course, here's my 2 SSRs, which, cut out and then go into my heat sinks. But that is it, folks. This is, really happy with this and how it turned out. Great wire flow on everything. Everything's nice and clean, labeled, colored, and Yeah. Power on. Bing. Speaking of the last little bit here on the panel, again, everything on this was about space and size and keeping it small. Uh, kind of going through some of the things that helped me achieve that. This much smaller timer. There's a bunch of timers out there. If you go to the Electric Brewery, he has a very large, very expensive also, but very large multi-function timer. You could literally program in all your hop additions and everything. The alarm will go off at every step of the brewing process, which is great. However, one, I didn't want to spend, I think it was like almost $200 for that timer. And I don't think it's also, completely necessary. This keeps track of my time and the alarm goes off, and really that's all I need. All I did was move my little, kitchen timer up to the panel essentially. And that was good enough for the beer I'm drinking. Other things that help me save space, I did want to go with just a plain LED so I know which element is on, but these switch LED combos, if you look at some other designs, this was like a whole nother like blue LED and then another switch, and I would have had to do another row of switches. Things I do not have room for, and in doing this with this, going to a 16-inch panel, I was able to go ahead and add in all my master timer and then timer switches or alarm switches rather for all my PIDs, which to me was worth doing, and it worked out incredibly well. So I've used all these brewing multiple times, and then even just the button here. Coming up to the EPO, something you could potentially do without. It was suggested to have it, and lo and behold, that for the exact reason it was suggested to use it, twice I've ran into a problem where I've actually had to smash that thing. One, I had one of my silicone lines blow out, and it was either beer or water, I can't remember which, but I mean it was everywhere, squirting all over everything. So smashed that, killed my pumps and elements right away. And then the other time too, I think I was draining water down too much, and it actually went below my element. And those things do not like that. And I was able to smash that right away, completely kill power, and saved all my components. So would highly recommend this. I really like the switch. They're a couple extra bucks. As you see, all this stuff fits in this very small panel. It can be done. All right, and here's my list of materials. And I did have a second tab for a second purchase where I broke this down, but I have consolidated into just a kind of single list. Know that some of these smaller things like these jumpers and end caps and stuff, you're going to want to count those yourself. But this is the bulk of it, and what, based off my design, what I needed to purchase in order to make my panel. To step through this, here's my panel I found on Amazon. That was the 12 by 16 panel. Another big ticket item that you need to have is that GFCI breaker at a 30 amp. As I mentioned, I did repurpose some things that I had on hand in order to wire it, just to save a couple dollars on my end. And then, all this too, I broke out into kind of the categories, and of course the total. Continuing through all my DIN rail components, the electronics of it, also SSRs and the PIDs, including my timer, all the multi-function switches and LEDs, all the probes, heating elements, and kind of all the ancillary stuff, just the wiring. And I bought a false bottoms for my brew in a bag kettle as well, but these are all cheaper items for the most part. Here I will point out a couple different places did have some wiring kits that I wanted to utilize, but they didn't have any in stock, and I ended up just buying stuff separately. But if you were to look at it, you should be able to get either one of these.
And this was it. Has all your links and everything to assist you, and that's it for the list of materials.
That's pretty much it. We covered the panel in depth, went through all the thoughts and design and everything that went into making that, and why I went the way I did, and obviously you can see how well it turned out. Covered the list of materials. Follow on to that is if you're watching this and you're thinking about going to electric brewing and maybe on the edge or whatever, just looking at price, I will tell you that this is kind of the big decisions that I've made in home brewing. You know, going to all grain was a huge one to me. That was a huge step, and never looking back. I was very very glad I did that. The next thing was actually stepping up to doing kegging. Never going back to bottles. Obviously, I only bottle beer if I'm bottling for like friends or something like that. And the next big step was doing electric brewing. Read up on it a ton. Obviously, when I was researching this panel, tons of articles, tons of forums from people of input, and absolutely, one of the best decisions I've made in doing home brewing. It is the benefits of electric versus doing gas. It really kind of frees up your brew day, and you're not worrying about carbon monoxide anymore, which is always a safety issue. That's nice. You can bring your brew setup now indoors if you want. If you're not doing that already, you can bring it in a basement. You still got to worry about humidity. However, you're not worrying about carbon monoxide. Efficiency, way more efficient. I know I was also too. I was burning through propane tanks incredibly quickly. I think on a boil once ran out and had to literally like just haul it to the store and get another refill so I could try to save my brew. Don't have that problem with electric, and like with that efficiency becomes the speed of it. I was wasting so much time in my brew day, about an hour to get my, or close to an hour to get my water up to mash temp, and then turn around and then a whole nother hour to get that up to boil. Just so much time that was just downtime. And I want to say now it's about 20 minutes. I'm at mash temp, and about another 20 minutes past that ish, I'm at a boil. So you know getting older is like time is your currency, and saving my time, that's worth it for me. And it really makes my brew day so much less stressful and everything. And it just kind of brought that element back to brewing, that you can just focus on the recipe design and all the things that you really love about it without having to mess with the propane and all the inaccuracies of it and everything. Things have been going really well. Again, I'm never going to go back to propane. I'm going to continue with my electric, and my next step here will be getting my pump and my next kettle and everything, so I can go to a full HERMS system and enjoy that benefit as well. So I know a lot of talking in this video. I appreciate you guys sticking with me. I hope you got something away from this, and can learn from my successes with this, mistakes with this, and everything. And hopefully this helps encourage you, or give you the information that you need to make your decision and whether or not you want to go to electric brewing. So thanks for watching, and hit like and subscribe. I'll probably have some more brewing videos, or kind of the next piece of building my brewery. So enjoy and have a home brew.